Hi everyone, my name is Anuj Solanki and I am a BTech final year student at IIT Mandi and my majors is computer science and my interest lies in AI, machine learning and app development, and I am also a Google Summer of Code contributor at the Linux Foundation, and you can contact me on the given email ID. So the today's agenda of this presentation is first I'll talk about what GSOC is, then I'll introduce the AGL voice assistant and what has already been done before the GSOC 24, and then I'll share the deliverables for the GSOC 24 and how the AGL voice assistant work, and then I'll give a quick demo for the AGL voice assistant, and after that I'll share some of the challenge I faced and my experience with the AGL. Now coming to the Google Summer of Code. What is Google Summer of Code? So the Google Summer of Code is a global open source program organized by Google every year for the students and the developers, and during this program the contributors contribute to a coding project under the guidance of some experienced mentors, and it's one of the best opportunity for the students like me. They can learn and grow, they can learn how to contribute to open source, and it's a good opportunity for the students. And now coming to the introduction to the AGL voice assistant. So it's a smart interface, voice interface designed for the automotive grade Linux, and it is used to control the HVAC, volume, fan speed, media. And here are some of the key features for the voice assistant. So the first one is the wake word mode, like we see in the Google Assistant, Hey Google, and in the Siri. And it also has on-device speech recognition using Vosk and Whisper, and it is used to execute voice command. And the AGL voice assistant can work completely without the internet connection. Now coming to the pre-GSOC work and background. So before GSOC 24 there was a voice agent service completely written in Python, and which is responsible to record and process the voice command, and then the voice command is sent to the speech to text model where the transcription happens, and after that the transcript is sent to the intent engine, which extracts the intent and executes that intent. And there was also a Flutter based client app which connects to the voice agent service via gRPC connection for all the services of the voice assistant. And now coming to the GSOC 24 deliverables. So before GSOC 24 the voice agent assistant uses Vosk for the speech recognition, and it is not very accurate and it is also very sensitive to the noise. So the main aim of the GSOC 24 was to improve the speech recognition using the Whisper AI, and to do that we need to create the Yocto recipes, and all the recipes are included in the Meta offline voice agent layer, which you can find in the Meta AGL devel layer. And after creating the recipes we also need to integrate the Whisper AI into the AGL voice agent service, and we also need to update the Flutter speech recognition app, which is a client, Flutter based client for the voice assistant. And as a stretch goal we also integrated the voice assistant into the Flutter ICS home screen app. So if you build the AGL IVI demo Flutter image with the voice agent feature enabled, then you can just directly use the voice assistant, as you do not need to have this Flutter speech recognition app into your system. And moving on to the next slide is the Whisper AI. What is Whisper AI? So the Whisper AI is a advanced automatic speech recognition software developed by OpenAI, and it became open source in September 2022, and it supports multiple languages for the transcription. Around 100 plus languages are supported, and you can install it easily on your PC and use it. But the Whisper AI is a little too resource intensive, so it is very tricky to use it on low power devices, and it also requires some heavy frameworks like PyTorch, so which makes it completely unusable on low power devices. And to fix that, we research about some other alternatives for the Whisper AI. So, and we found the Whisper.cpp. So Whisper.cpp is a high performance inference for OpenAI Whisper AI, and it's completely written in C++, and it doesn't require any dependencies, and all the original Whisper model are converted into the ggml file format, which using which we can completely skip the PyTorch and other heavy dependencies. And here this slide includes some more detail for the Whisper CPP. Basically it's lightweight and fast and efficient for the embedded targets. And we also installed the Whisper CPP on the EGL running on a Pi 5, and here we can see that when we used the tiny model, it took 3.2 seconds for a 4-second audio file, and when we used the base model, it took around 8.7 seconds for the same 4 seconds audio file. So here we can see that the tiny models works nearly in real time on a Pi 5, and it is a good thing. So now I'll explain you about how AGL voice assistant works. So there is a client app with which the user interacts, and there are two modes in which the voice assistant can be used. So the first one is the wake word mode. If you enable the wake word mode, the service start listening for the wake word, and as it detects the wake word, creates a GStreamer pipeline to record the voice command. And after the voice command is recorded, the voice command is sent to the speech to text model, where the transcription happens, and after that the transcript is sent to the intent engine, where the intent engine extracts the intent from the text command and executes that intent, and the response is sent back to the client app. And in manual mode, the manual mode is very similar to the wake word mode, but in this you need to manually press a button to start the voice assistant, and then it goes in a similar way as it goes in the wake word mode. And now coming to the meta offline voice agent layer. So it's a Yocto layer for the AGL voice assistant, and it can be found in the meta AGL devel layer. And this layer includes all the recipes for the Whisper CPP, WASC, and the NLU engine. And this layer depends on the external layer, which is Meta Python AI layer from the Open Embedded Layer Index. And this layer also includes the recipes for the OpenAI Whisper AI. So if you want to use the OpenAI Whisper AI, then you need to add these recipes into your image, and then you can test it. And now moving to the next slide is the voice assistant demo with the Whisper AI. So here on the right side is the Flutter ICS home screen app, in which we integrated the voice assistant client. And now on the settings page, you will find a voice assistant toggle button, which can be used to enable or disable the voice assistant. And inside the settings of the voice assistant, there are a couple of the settings that you can change, and you can also select the speech to text model. There are two options for that, Whisper AI and the WASC. And for this demo, I have selected the Whisper AI. And here you can also enable or disable the wake word mode. Now here, as I enable the wake word mode, the service has started listening for the wake word, and now it's listening for the wake word hi automotive. And now as it detects the wake word, it will start the voice assistant. So here you can see that when it detected the high automotive, it has started the voice assistant. Now I'll try to change the volume using the voice command. And here you can see that the spoken command is changed the volume to 100%, and the volume has increased to 100%. And here also you can see the intent for this text command is the volume control, and the value that we want to set is 100. And you can also use this button to manually start the voice assistant. Like now I will try to change the HVAC temperature using the manual mode. And here the current temperature is 26 degrees Celsius. Now here you can see that the spoken command is change the temperature to 30 degrees, and the intent is HVAC temperature, and the value is 30, and the value has also been changed to 30. And now coming to the potential future work. So the current voice assistant wake word detection is done by WASC, and it is very noise sensitive. So we can add some noise reduction and filtering techniques to reduce the noise. And we can also add some cloud-based LLM to better understand the complex command and execute complex commands. And here on the next slide, I have shared some of the challenges I faced during the GSOC. So first one is the Yocto project and the Yocto recipes. And since I was very new to the Yocto, and I found it a little difficult in the initially, but my mentors helped me to understand the Yocto, and I also followed some of the documentation. And I also learned a lot of new technologies like Yocto, gRPC, Linux, Raspberry Pi. And now moving to the next slide is my experience with the AGL. My experience with the AGL is very positive, and we used to have weekly calls on every Monday where we can share our progress and discuss and resolve any issues we encountered in the week. And I also had some one-to-one calls with Ian Simon where he explained me about the Yocto and also helped me in resolving all my issues that I had. So the overall experience with AGL is very great for me, and I'm very grateful for this opportunity. And here I have attached some of the resources and the links that are used in this presentation and the voice assistant. Yeah, thank you. Any questions?
Hello everyone. Thank you for joining this presentation on the AGL demo control panel, which was completed as part of my Google Summer of Code project for the year 2024. My name is Suchinton Chakravarty, and I'm a computer science graduate from Amity University, Noida, India. And currently I'm working at Sienna as a GTS engineer, and I have contributed to AGL as part of Google Summer of Code 2023 and 2024 under the Linux Foundation. And I have also experience as a SD intern at FOSSI IIT Bombay. So this presentation will cover the following topics. We will start with understanding what GSOC is. I will explain what my Google Summer of Code deliverables and contributions were, and I will introduce you to the AGL demo control panel. We'll talk about the Kuxa data broker and Kuxa WAP, and go over how the control panel works. We'll also talk about how we're using Carla with AGL. Then I will showcase a demo about for my project. And lastly, I will share with you my experience with AGL and GSOC. So, what is Google Summer of Code? Google Summer of Code is a year by year event conducted by Google during the summer vacations where students and professionals can contribute to open source projects. And basically, Google facilitates this interaction between these organizations and the students and professionals to encourage open source contributions. The projects are done in collaboration with experienced mentors, the whole community for that particular project. And students and professionals are able to gain a lot of career prospects and experience in software development and improve their code skills, just in general network in the wider open source community. So let's go over the Google Summer of Code 2024 deliverables and contributions. So I built upon the work that I had previously done for the AGL Demo Control Panel project as part of Google Summer of Code 2023 by porting the application from Qt5 to Qt6 framework. I added custom widgets and animations to various components of the control panel. I also added file playback for the Carla simulator. We added support for new controls and keypad features, updated some of the UX UI elements. The recipes and dependencies for the control panel were also updated. We also updated the AGL documentation accordingly. So here's an introduction to the AGL demo control panel. So the control panel is a Qt 6 application uh, developed to simulate canvas signals using Kuxa.val and for the AGL demo apps. So it also supports Carla file playback. It uses gRPC and WebSocket connections to the data broker server running on these images to feed the values for the simulations. Uh, the control panel is written in Python and it uses various custom elements using the Qt 6 and QML framework. It allows us to test and showcase the various AGL apps in a very user-friendly and interactive way. So, what the Kuxa Data Broker is an open source project which allows us to abstract some of these signals used by these AGL apps, such as vehicle speed, the engine RPM, and the tire pressures using the VSS standard, which reduces complexity. It makes the code more reusable and more abstract in that way. So the AGL demo applications subscribe to these signals, and the data broker facilitates setting and getting of these values. The AGL apps are currently using the data broker, which is written in Rust, for handling these VSS signals. So how the AGL demo control panel works is basically we have these widget modules which render the UI elements using the Qt6 and the QML components. We have the Kuxa client component which connects to the data broker using gRPC, and the config.ini file helps us set the preferred settings for the control panel. So as you can see in the diagram, the UI elements are rendered and they have their own uh, backend logic on how the signals are handled. And the Kuxa client module in the demo control panel helps the communication with the data broker on the target AGL app. You are able to see the config.ini file provides a lot of settings to configure the full screen, toggle a lot of the demo controls. It also adds support for the file playback. You can enable or disable it, and various other settings that you might want to configure for your application. As you can see, once you launch the control panel, you will find the dashboard and you can navigate to the other pages. So you have the instrument cluster from where you can set the engine RPM, the vehicle speed, the drive mode, the fuel uh, levels and the coolant temperature, the tire pressure, and you can also toggle on and off the file playback and vehicle simulator demos. You can also navigate to the HVAC page where you can set the individual HVAC controls, so the temperatures and fan speed can be set using the sliders and the scroll wheel. Then you can navigate to the steering wheel controls. You can also go to the keypad inputs, which are used to switch between the various AGL demo uh, demos on the VMs that we present. And then there's finally the settings page where you can set the various parameters of the data broker, and what protocol you want to use, what you want to display, and whatnot. Uh, so what Carla is an open source simulator used to simulate vehicle data in a very realistic way. So we wrote the Carla to CAN script, which runs alongside an existing Carla simulation to fetch uh, data such as the vehicle speed, the engine RPM, and convert it into its equivalent CAN signal as per AGL standards, and it dumps that on the specified CAN interface. And the record playback script then takes those signals and dumps them into a plain text file with the timestamp for later playback. The playback of these files does not require the simulator to be running in real time, so that helps us put this playback file in a image and run it without any kind of dependency on Carla when we do want to simulate these values. Uh, the scripts are available and they're part of the AGL Demo Control Panel project. You can enable the file playback in the config.ini settings. And if you have it disabled, the vehicle simulator, the default vehicle simulator will be used as a fallback. And yeah, uh, next I will showcase the project demo.
On the left, you can see the Flutter IVI uh, demo running on a Raspberry Pi, and on the right, you can see the AGL demo control panel. So the control panel can be configured from the settings page, where you can provide details to connect to the data broker server. These values have already been defined in the config.ini, so these are the default values. You may change them as required. Once you start the client, it will connect to the data broker server and the status will reflect the same. So once it's connected, you can navigate to the instrument cluster page, and if I change the values here, you will see them update on the Flutter IVI demo as well. So these are some of the values that you can change. This is dependent on the demo, what values it provides. You can also manipulate the tire pressure values. So as you can see, the top right tire is at 230 kPa. I can change that, increase or decrease it. I may also manipulate other wheels, right? I can hide this window. We can then navigate to the HVAC page, which provides controls to change values for the HVAC control. Here I can decrease the fan speed. Here I can change the left and right temperature. I can drag these spin wheel values as well, both for left and right. We can also navigate to the steering wheel inputs. These provide inputs for various other demo apps as required. These are optional. You can also see the newly added keypad feature, which allows to switch between demo setups. So it executes certain API calls on the backend. Again, optional. You can navigate back to the instrument cluster page, and one of the features that we added this year was the file playback. The playback file is generated by running a couple of scripts alongside a Carla simulation, which generates the playback file. Once the playback file is generated, you can provide that to the AGL demo control panel, and so the playback looks something like this. While the playback file is running, you can also interact with the other widgets. So here I am updating the tire pressure. And the fuel level. And you can also interact with the other pages. Once the playback is done, you can also disable it.
So coming to my experience with AGL and GSOC, over the course of these 2 years, uh, I have gotten a good understanding of the open embedded Yocto project and how the layers and recipes work. I was also able to become quite proficient with the Qt framework and Python and learn about gRPC and WebSocket protocols. I was also able to implement multi-threading and a lot of design patterns into my application. And I had the opportunity to work with the open source community and learn about the Calda simulator and the AGL platform. And it has been a great opportunity to interact with the wider open source community through Google Summer of Code. And my mentors were really helpful, and the whole community was very supportive. And I would highly recommend anybody getting into open source to start with uh, AGL and Google Summer of Code and the Linux Foundation. Uh, so you can find some of the resources used for the presentation here, and for a more detailed uh, breakdown of the AGL demo control panel, you can refer to the AGL documentation and the various links provided here. Thank you.